All right, video notes 1.1. This is the official first video of the curriculum for the first semester of Integrated Math 2. Be mindful to listen the whole time, guys, because there might be something that if you're not paying attention to on this video, you're not listening, you might not get full credit. So let's go into it. First, let's talk about the title here. We're just talking about adding and subtracting polynomials. Pretty straightforward. Just adding and subtracting like terms. The subtracting is where students tend to have the most problems, so I want to focus most of our energy on that because you'll see here they're subtracting in example 1b. But let's talk about just adding first. That one's pretty straightforward. What I like to do when I'm adding is I like to, since all I'm doing is adding, I don't have to worry about any of the signs changing. They're all just going to stay the same. So all I have to do is line up the like terms. And you could do this with highlighters. You could do this with just like circles and shapes. But let me show you like one of the things you could do here. Like we could do a red circle around the ones that have an n squared, and just an n squared. So those are like terms. I could do like a triangle around ones that just have an n. I could do a square around ones that don't have any n or any variables. And see, now I can clearly see what my like terms are. You don't have to do this if you could just tell what the like terms are and you could just go for it, but this is just a way that kind of helps you see it. You could use a highlighter too. You don't have to do shapes. Whatever just helps you see it. But if you see it right away and you want to just go for it, then just go for it. So what I like to do then is I like to just line up my like terms. So I got 5n squared and 3n squared, negative 4n and negative 5n, and 7 and negative 12. These are all like terms. And since I'm adding, I'm just going to go ahead and add. 5 plus 3 is 8, and I just make that n squared. A common mistake here is that students see the n squared and the n squared, and they think, oh, that's n to the fourth. It is not. Remember, n squared means n times n, not n plus n. So Ms. Velasquez likes to tell a story about how this is like saying 5 double doubles plus 3 double doubles. That would make 8 double doubles. It doesn't make 8 4x4s, right? That's not what it does. I'm talking about in and out here, in case you don't know. All right, let's keep going. Negative 4n, negative 5n, that's negative 9n. And 7 and negative 12, that's negative 5. Boom. That's it. That's all there is to it. So let's talk about example 1b now, because this one says subtract. And anytime you have a subtract in front of parentheses, you need to think about distributing that negative to every single term. Let me kind of draw that out for you here of what I'm talking about. I'm saying that that needs to go to each of these terms. And so what I'm going to do before I line it up, again, you could do your circles here. Actually, you could go like, oh, let's make those circles. Let's make, that a triangle, just so we could see them all lined up. You could totally do that. But what I'm going to do is, as I line these up, I'm going to distribute that negative symbol right there. So that's a negative in front of a positive 3x squared. So that becomes a negative 3x squared. All right. That's a negative in front of a negative 3x. Well, negative to a negative makes a positive. So now I'm going to say positive 3x. And lastly, I have a negative in front of a positive 5. That makes that a negative 5. And now that once I've done that, once I've distributed the signs to each one, see how I changed them all? Positive, it was positive, negative, positive. Now it's negative, positive, negative. Now that I've distributed the signs, it's really just like adding. That's it, just like adding that whole thing. So I could just go straight down. 2 minus 3 is negative 1, and I just write that as negative x squared. Negative 8 and positive 3 makes negative 5x, and negative 6 and negative 5 together makes negative 11. This is also one where students can make mistakes, right? A negative 6 and a negative 5. Think about this. If you dug a hole 6 feet deep, and then you dug another 5 feet, you'd be 11 feet total down, right? But what some students try to make the mistake is they think, oh, negative, negative, it cancels out, and they think, oh, we're somehow 11 feet up. No, we're still going down because these are both negative, right? And they don't cancel each other out. If you went down 6 feet and down 5 feet, you wouldn't be like down 1 feet, right? You would be down 11 feet. So that's why that's the answer. Okay. So that's example 1b. I want you to try now, practice one on your own. Give it a shot. Remember, there is a negative sign here, so don't forget to distribute that negative to every term before you line it up, or as you line it up. All right, give it a shot, pause the video, and then check back when you're ready to see if you did it right. All right, I distributed the negative to each term, making this, since these were all negative, it made them all positive. And then I just added straight down. 12 and 5 is 17, negative 9 and 3 is negative 6, 5 and 3 is 8, and so there's my answer. That's all I had to do. Notice I didn't do the shapes this time, right? That's really only if you need it, so you don't have to do that every time. I'm just showing you little things that might help you, but not at all a requirement. Okay, let's talk about example 2. The language here is a little bit tricky. So what I want you to do on this one, see it says subtract this whole thing from this whole thing. For the time being, what I want us to do is just look at the first numbers, okay? Let's pretend, just for a second, that this sentence said subtract negative 5 from 7. Subtract negative 5 from 7. Okay, even though it's not written in that order, what that really means, right, what that really means is that we're saying 7 minus negative 5, right? That's what it would mean to say subtract negative 5 from 7. Isn't that how you would write it out? So we have to realize that this is in front. It's really saying this whole term minus this whole term. So what I'm going to go ahead and do is I'm actually going to write 7a squared minus 3a minus 9. And then I'm going to say minus parentheses, and then I'm going to put the second term, negative 5a squared plus 6a minus 4. All right, now that we've done that, you can see it looks just like the problem above, right? It looks just like this. We could put parentheses around this first trinomial, but it really doesn't matter because now we're going to distribute this negative, put it underneath, and just add to make our lives super easy. But it's really important that you recognize what's going on there in the language, right? And the easy way to do that is to think about the first number. Subtract negative 5 from 7 would look like that. So that means that subtract negative 5a squared plus 6a minus 4 from 7a squared minus 3a minus 9 would look like this. So let's actually do the math now. I'm going to distribute that negative sign, right? Distribute it to every single term. So negative negative makes positive. So that's a positive 5a squared. Negative positive makes negative. So that's a negative 6a. And then negative negative again, that makes positive 4. And then what you can see here, if you did this right, all the signs should be different, right? Because this is negative, positive, negative, and this is positive, negative, positive. All the signs should be the opposite. All right, I'm ready to just add. 5 plus 7 is 12. Negative 3, negative 6. Again, we're just digging a hole deeper. That's negative 9a. And negative 9 and positive 4. What I do in these ones, just so you guys know, a little quick way, because sometimes students get confused on this, is I just say, like, okay, what team is winning, the positives or the negatives, right? And the negatives are clearly winning, right? There's more negatives than there are positives. So right away, I'm just going to say negative. I know it's going to be negative because the negatives are winning. Now, since one's positive and one's negative, I just got to find the difference between these two numbers. I can ignore these signs for a second and just say, okay, so what's 9 minus 4? Well, that's 5. So I'm just going to go minus 5. And that's how I do that. That's how I do problems when there's, you know, a negative number that's bigger than a positive. Sometimes students get confused on doing that in their head, but that's really just like saying 9 minus 4, but it's negative. That's all it is. Okay, so I got a similar problem for you guys here on an example or a practice 2. I want you to try that one on your own. Again, remember, look at the language and think about how I set up the order in the last problem. But go ahead and give this one a shot on your own. All right, so it's like saying subtract 2 from 8. Remember, that would be like 8 minus 2, so that's why I put the 8, or the trinomial with the leading coefficient of 8 first, and the trinomial with the leading coefficient of 2 second. And I said minus and then parentheses, because I'm subtracting this whole thing. So then I changed the sign in every single one. So this is positive 2, but I'm subtracting, so I made it negative 2. This negative 7 I made positive, this positive 11 I made negative, and now all I have to do is add. And I get 6y squared minus 2y minus 4. Perfect. Okay, remember I said there's going to be a little secret something here if you're paying attention. Right over on the right-hand part of your paper, wherever there's space, I just want you to write down your favorite TV show. Just your favorite TV show, you're going to write it down there. If you don't write something down there, you're not going to get full credit for these notes because I require that you are listening to these notes. So put something over on the right side of the page. Thank you for listening. All right, let's talk about example number 3. What we're doing now is we're trying more than one variable or two variables. Notice we have x's and y's. And so we have to make sure that the terms are all the same, and we also want to line them up again. But first, let's do our little shape method thing and see if we have all the same terms. All right, so first off, I have x to the fourth. So I'm looking for something that just is x to the fourth. Well, that's just an x to the fourth. Okay, next up I have 6x squared y. So I want an x2 and then a y. Ah, this is not an x2, it's just an x. So I'm going to make this maybe, I'm going to make this like a, I don't know what you would call this, but like a sun or something around this. Okay. And then I have a 7y and a negative 3y. Okay, so those are the same. But I do have a problem. Maybe I should even use a different color here. Yeah, to see that those do not match. So when I go to line these up, I cannot line up this one and this one because they're not the same terms. This is an x squared y, this is an xy. These are different things entirely, and so I can't add or subtract them together. Okay, I'm just adding, so I don't have to worry about distributing any negative, but I could see down here in practice 3, you're going to have to think about that. So let's go ahead and line things up and go for it. All right, so I have the 7x to the fourth. I'm going to put the negative 2xy just over here. And I have the negative 3y. Okay, let's go ahead and add it up. I would get 8x to the fourth. For this one, I'm going to just, there's no other term like it, so I just get plus 6x squared y. For this one, 7 minus 3, that's positive 4y. And there is no other term like this, negative 2xy, so I just do negative 2xy. And that's it. All right, for practice 3, I do want to remind you that there's a negative here, so you're going to need to distribute that to every term. So let's just kind of make a note of that, right? You're going to distribute that to every term, and then you can line up your numbers and add them. Go ahead and give that a shot now. All right, so you should have got a negative 9, a positive 4, and a positive 8, giving you negative 5x to the fourth, positive 11x squared y squared, and positive 9y to the fourth. All right, one more practice problem for you. Remember, this one says subtract 3a to the fourth plus 2ab squared plus 11 from 7a to the fourth minus 4a squared b squared plus 6. Now, remember, think of just the first term. Subtracting 3 from 7, what would that look like? 3 from 7. That would look like 7 minus 3. So that gives you an idea of how to set this whole problem up. Don't forget to distribute all your parentheses, distribute negative to everything inside the parentheses, right? These are all one big polynomial, so if you're subtracting something, you got to distribute to every term. All right, go ahead and give that one a try. Okay, so this is what I was talking about. We have to do this whole thing minus this whole thing. So since we're subtracting this whole trinomial, we have to distribute that negative to every term. So I went ahead and did that, and as I did that, I wrote it underneath the common term. So that's negative 3a to the fourth, negative 2ab squared, but there is no other things that are an ab squared, so I made that its own color green. And there isn't anything that's a squared b squared, so I made that its own color blue. And then negative 11. Then when I add all these together, I got 4a to the fourth minus 4a squared b squared. And then I put the 2ab squared here because technically you're supposed to go in order of the highest degrees. That's a little 2 right there. I know it kind of bleeds together. That's a 2. That's a 2. So you're supposed to go in order of the highest degrees. These are the same, but this is the highest of just one, so it wins. Let's see, we have a total of 4 a's, a total of 2 a's and 2 b's. That's a total of 4 degrees. And then there's a 1 here and a 2 here, so that's 3. So that's kind of sets the order that it's supposed to go in. If it's not in that order, it's not wrong. It's just not proper. So it's not really a big deal, but it's something you should know. And then 6 minus 11 is negative 5. Okay, that's it. Don't forget to answer the question or ask me a question on the video. All right, I'll see you guys on the next one.